Hello friends and welcome to Hypercar Engineer Explain. In today's video we are going to learn about the load transfer that is happening in a vehicle when the vehicle is taking a corner. So let's dive into the video. In vehicle dynamics, the load transfer has been classified as three. The first one is the longitudinal load transfer, second one is the lateral load transfer, third one is the diagonal load transfer. The longitudinal load transfer happens in a way that is parallel to the vehicle wheelbase. Lateral load transfer happens in a way that is parallel to the vehicle wheel track, and it will be from inner to outer or outer to inner side of the wheel. And the diagonal load transfer will be same as that of lateral load transfer, but it happens in a line that is in a diagonally opposite manner. In this video, we are going to explain the load transfer in three different cases. The first one is the driver will be entering into a corner and he will be trail braking, which means he will be using a combination of braking as well as steering input. And the second case, the driver will be exiting the corner and he will be accelerating as well as reducing the steering input. And the third case, the driver will be entering into a corner, but instead of trail braking, he will be accelerating as well as giving steering input. For the first case, the driver is entering into a corner as well as he is using trail braking. Trail braking is a fancy term that is used when the driver is using a combination of braking as well as steering input. So in the first case, he will be using braking as well as he is giving steering input. So there will be lateral load transfer, longitudinal load transfer as well as diagonal load transfer. Now we are going to look at how this, in which direction this load transfer will happen while trail braking and entering into a corner. The longitudinal load transfer, we know that it will happen when the vehicle is accelerating or braking. In this case, the driver is giving braking. So while braking, the load transfer will be from the rear axle to the front axle. So the longitudinal load transfer, the load will transfer from the rear to the front. So most of the load will be at the front than the rear. And the lateral load transfer happens from inner to outer wheel or outer to inner wheel. In this first case, the load transfer will be from inner to the outer wheel. Consider the vehicle is taking a right turn, the lateral load transfer will be from the right wheel to the left wheel, which is outer wheel. So most of the load will be on the left wheels when the vehicle is taking a right turn. And the diagonal load transfer, as I already said, it will be from inner to outer or outer to inner, but in a diagonally opposite manner. So in the first case, when we are entering into a corner and the driver is trail braking, the diagonal load transfer will be from the rear inner wheel to the front outer wheel. So most of the load will be on the front outer wheel than the rear inner wheel. So the less laden wheel will be the rear inner wheel, and most of the load, the highest loaded wheel in this situation will be front outer wheel. You can see this if you closely observe a photo of a vehicle that is taking a corner using trail braking. The most of the load will be on the front outer wheel. So in some cases, the wheel, if the droop is less, the rear inner will get lifted from the ground. Now we are moving to the second case. In the second case, the driver is exiting the corner and he will be using a combination of throttle as well as steering input instead of trail braking. So the driver will be reducing the steering input as well as he will be giving throttle for accelerating the vehicle, and he has been completed the apex and he will be exiting the corner, and the load transfer will happen in a different direction. The longitudinal load transfer will be from the front axle to the rear axle, because the phenomenon is happening or the pitch is happening in a squatting direction. So the load transfer will be from the front axle to the rear axle, and the lateral load transfer happens from the outer to the inner. Why? Because we know that at the apex, when he has given the maximum steering input, the most of the lateral load transfer has been happened and most of the load will be on the outer wheel. And after when we are exiting the corner, the load that is came to the outer has been going to the initial position. So the load transfer will be from the outer wheel to the inner wheel. So if the vehicle is taking a right turn, the load transfer at exiting the corner will happen from left to right. And the diagonal load transfer happens just opposite to the previous case. So the diagonal load transfer happens from the front outer to the rear inner. So in the trail braking situation, most of the load has been came to the front outer wheel. So in exiting the corner, the load will go back to the initial position, which is the rear inner wheel. So this is how the load transfer happened in the case 2. Now we are going to look at the case 3. In case 3, the driver will be entering into a corner, but instead of braking, he is using acceleration. The driver is giving more steering input, but he is at the same time accelerating. So this will happen in most of the faster corners. In faster corners, the driver will be giving throttle because he doesn't need to slow the car down that much, because he will be easily cover that corner at a higher pace. In this case, in combination of steering input and acceleration, the load transfer is slightly different from the case 2. So the longitudinal load transfer is same as that of case 2. The load transfer will be from the front axle to the rear axle because it's accelerating and it's a positive acceleration. And the diagonal load transfer and lateral load transfer will be different from the say case 2. So in this case 3, the lateral load transfer happens just like the case 1. The load transfer will be from the inner to the outer. If the vehicle is taking a right turn, the load transfer will be from the right to the left. So in the case 3, the load transfer will be from inner to the outer. And the diagonal load transfer is also different from case 1 and case 2. In this case, the diagonal load transfer happens from the front inner to rear outer. You can imagine that the load transfer will happen, the diagonal load transfer will happen from front inner to rear outer. The lateral load transfer will be from inner to outer. The longitudinal load transfer will be from front to rear, and the diagonal load transfer will be from front inner to rear outer. So in this case 3, when the driver is accelerating and giving steering input, most of the load will be on the rear outer tire instead of front outer. Rear outer tire will have most of the load, and the less laden tire will be front inner tire. This is the reason why if the car is entering into a corner with higher pace, if the corner is a fast corner, the front inner tire will get lift from the ground if the car has less droop. The load transfer is also directly proportional to the weight distribution of the vehicle, the static weight distribution. You know that most of the rear wheel drive vehicle have a weight distribution of 60-40. The 60% of the weight will be on the rear axle and 40% of the weight will be on the front axle. And most of the front wheel drive vehicle have front engine. So for that chassis configuration, most of the load will be on the front and less load will be on the rear. We know that we need more load traction, more normal load means we will have more traction on that particular tire. So for generating more traction, we need more coefficient of friction, as well as we need more normal load. More normal load means more vertical load. So while braking, if the car is rear wheel drive vehicle, we need more traction at the front. So if the car have higher load on the rear, the load transfer, longitudinal load transfer will be to the front. So the load will transfer to the front, giving that front side more traction, and the vehicle will have better stopping distance. And at the same time, if we are accelerating, most of the load is at the rear, and in combination of acceleration, in most of the cases we are not going to turn at the time of acceleration. So most of the load will be on the rear. So there will be more traction at the rear. So the rear tire is the driving wheel. We will get more traction, means the car is able to accelerate more quickly. For front engine front wheel drive vehicle, the load transfer while acceleration will be similar to the old case. So the load transfer will be from front to the rear, which is not beneficial for the vehicle because it is a front wheel drive vehicle, so we need more traction at the front. That's why the vehicle has been designed to have more weight at the front to generate more traction while accelerating. So at the same time, braking, most of higher load will be at the front, so they will use more brake pressure at the front for reducing the stopping distance and to get more traction at the time of braking as well. Okay friends, this is all for today's video. Thank you for watching, and don't forget to give a thumbs up if you like this video, and subscribe to my channel to get notified when I make a new upload. Thank you for watching. Have a nice day and bye.